All right, so what I'm going to show you here on this problem, this is section 11.4 in class problem, and it's problem number 2, is how to complete this problem, which talks both about empirical and molecular formulas. Okay, so remember our key with empirical and molecular formulas is this. Right away we see this problem. It says eucalyptic leaves are found as a food source for panda bears. Eucalyptol is an oil found in these leaves. Analysis of this eucalyptol indicates it has a molar mass of 154 grams per mole and contains 77.87% carbon, 11.76% hydrogen, and 10.37% oxygen. Okay, so remember the first thing with these problems is to go ahead and cross out your percent and make everything grams instead of our percents. Now, we're going to list each of these items out now as grams. And so we're going to have the first one listed is going to be 77.87 grams of carbon. I'm going to give a little bit more space here. And then I'm going to put 11.76 grams of hydrogen. And then our final element that we had to work with here is 10.37 grams of oxygen. Okay, now key to all of these is grams is a great number to measure with, but we have to get these into moles. So we're going to break each of these into their moles. And remember, we're going to divide by their molar mass. So we'd say times, we draw our line. We take out the knife hand, cancel diagonal. So we have grams of carbon. On top, we have moles of carbon. You look on the periodic table, the molar mass of carbon is 12.01 grams to every 1 mole. So while I'm here, I'll calculate this. I take 77.87 divided by 12.01, and I get here, I'm going to go out to 3 decimals. I get 6.484 moles of carbon. Okay. We go to hydrogen and do the same thing. Just remember it has a different molar mass. I say times, I draw a line. The molar mass of hydrogen is 1.008 grams of that hydrogen to every 1 mole of hydrogen. And so again, I divide this out. So 11.76 divided by 1.008. And I get to 3 decimals here, 11.667 moles of our hydrogen. And then we divide the last number here by the molar mass, this time of oxygen here. So we say times, and draw our line. So we'd say times, draw our line. Grams of oxygen cancels below, so we'd have 16.00 grams of oxygen to 1 mole of oxygen. And when we do that, we take 10.37 divided by 16. We get to 3 decimals, 0.648 moles of O. Now, this is kind of an odd step here, or at least I view this as an odd step. We have numbers all the way here on our right. Okay, so we have numbers all the way here on our right. We look at these numbers and ask ourselves, hey, which one is the smallest? Well, that 0.648 moles down here with oxygen is the smallest. So every single number here on the right needs to get divided by this 0.648. Okay, so we divide each of these by 0.648. Divide each of these by 0.648, and we'll see what we get here. Okay, so if I take 6.484 divided by 0.648, I get 10.006, but that's good enough, close enough to exactly 10 moles of carbon. Okay, then we do the same thing for hydrogen. 11.667 divided by 0.648, and I get 18.00 and then some numbers. Again, that's close enough to the whole number 18 moles of H. And then 0.648 divided by itself is exactly 1 mole. Now, at this point in time, the numbers I have written in black now, we would look and we would ask ourselves, are these all whole numbers? Well, in this case, they are, so we're not going to have to do anything. But if they weren't whole numbers, we would have to multiply all numbers until they are whole numbers. Now, I always say this is like an algebra problem. If you multiply one element by some number, you have to multiply every element here. The nice thing here, we don't have to do that. These are all whole numbers here on the very far right-hand side. And so right now, we can determine our empirical formula. Okay, so out here, I'm going to choose a different color to write with here. Our empirical formula is going to come exactly what we have written here in black. Okay, so I have my empirical formula, which remember is the lowest whole number ratio of our elements or our atoms involved. And so we just write these in the order they appear in the problem. So we'd have carbon, and there's 10 moles, so the subscript would be 10. There is hydrogen, which has 18 moles, so the subscript is 18. And then our oxygen, there's only one O for oxygen, so we'd simply put O. All right. So right here, this is our empirical formula for eucalyptal. All right. So this answers one of the questions to allow us to get to the molecular formula. Now, this again is the empirical formula. What you would do is this: you would get the molar mass of our eucalyptal. And if I did that real quick in my calculator, if I took 10 times the molar mass of carbon plus 1.008 times 18 moles of hydrogen plus 16.00 from oxygen, my molar mass, to 2 decimals here, my molar mass of our empirical formula is, and I'll put this here, our molar mass is 154.24 grams per mole. Okay. Now, to find out the molecular formula, we have to take the found molar mass that is given in our problem, and I just circled there in orange, and we have to divide it by the molar mass that we just found from our empirical formula. Okay, so we determine this ratio is what it is. So I'm going to start out, I'm going to say, okay, in orange, from the problem, we have 154 grams per mole. We are going to divide this number by the molar mass of our particular empirical formula, which is also 154.24. And so 154 divided by 154.24, if you put that in your calculator, yes, you'll get a little bit below 1, but that's close enough in our value here to just say, hey, this number is close enough to that whole number 1. Now, what that means is that you have to take the empirical formula and you have to multiply everything by 1. And I know it seems ridiculous that I'm writing this down, but it shows you, hey, we use the given molar mass, we divided it by the empirical formula's molar mass, and we have to multiply everything by 1. So in this case here, if we multiply everything by 1, our molecular formula and our empirical formula will actually be the same, which is okay to have that. All right. So to finish this problem out, we would have C10H18O, and this right here would also be our molecular formula. All right. So hopefully with this information, you can complete the other problems from section 11.4 in class problems.